continuation with the previous video, learning about fundamental principles of counting and permutation, here we have an important result. That is, if we have n subjects of P1 items which are alike of one kind, P2 are alike of another kind, P3 are alike of third kind. Suppose we have it like this, our formula for number of permutation of then these n objects will be n factorial by P1 factorial into P2 factorial into PR factorial. So let's see following examples and understand how this result looks like. For example, we take a combination log, okay? So that is numbered from 1 to 30 where 1 and 30 are inclusive. How many different log combinations are possible? Assuming no number is repeated here. So, in permutations, we always have two different problems coming up, repetition and without repetition. So, here no number is repeated is the given question. So, we can write it as 30p3 where we will expand the formula using the given condition. So here we have 30 factorial by 30 minus 3 factorial. Since no number is repeated, we can directly write our R as 3. So 30 factorial by 27 factorial is equal to 30 into 29 into 28, that is equal to 24,360. Now, the previous slide we have learned what is this problem. So for this problem, I will explain a problem or explain with this problem. In how many different ways can the letters of the word leading be arranged in such a way that vowels always come together? Okay, so here the question is, we have the letter leading. In leading, we are supposed to find how many vowels are always coming together. Here we use the formula which we have learned earlier, n factorial by n1 factorial, p2 factorial and pn factorial. Now let's see here. The word leading has 7 different letters. We see here leading has 7 letters. Here we have 3 vowels E, A and I. Now the question is, all these vowels should come together. It should not get separated. And what are consonants we have? L, N, D and G. So these 4 letters can be arranged in any other form. Similarly, E, A, I also can be arranged. So we from the question we know that E, A and I should always come together. So the arrangement will be 4 plus 1, that is equal to 5 factorial. So when we find 5 factorial, it is nothing but 5 into 4 into 3 into 2 into 1. So when we expand this, we will get 120 ways. The vowels A and I are arranged among themselves because it can be I, E or I, E, A. So it has different arrangements. So we take it as 3 factorial. 3 into 2 is 6 ways. Now our required number of ways will be 120 into 6. So that will be equal to 720. You can wonder how this will be applied with the previous problem. Now I will explain that with the next problem. How many different ways can the letters corporations be arranged that the vowels always come together? Now, in the word corporation, we treat the vowels, we have here O, as one letter. CRPRTN, yeah, as one word. So here we have 6 plus 1, 7 letters. Okay, 6 consonants and all the vowels taken together, we have plus 1. So here, number of ways arranging these letters will be 7 factorial by 2 factorial. Why we are giving 2 factorial here? One of the consonant is repeating. R is getting repeated and this is how the formula works. We have n subjects and one of the subject is repeating twice. So that will be P1 of one kind. So n factorial by P1 factorial. So that will be 7 factorial by 2 factorial. So we will get, when we expand, we will get the result as 2520. Now we have 5 vowels Similarly, what we have done for the previous corporation for consonants, similarly we have to do that for vowels also. Now we have five vowels in which O occurs three times and the rest are different, so that will not be a problem. So 5 factorial. So whenever we have five different letters, we have 5 factorial by 3 factorial. So we have subjects n divided by p1 factorial. So p1 factorial is nothing but it is of one kind. So 5 factorial by 3 factorial will be equal to 20 ways. Now we will multiply 2520 into 20. We get the answer as 50,400. Hope you understood what is the result which is given here. So nothing but whenever we have this formula, whenever we have letter corporation and the letter, and in that particular word when the letters are repeating, we will divide that. When we have when subjects and p1 of one kind is repeating, we will divide it and we will solve the problem. We will continue the series with corporations combinations in the next session.